Welcome back. This is our second lesson in week 7, and we're looking at binomial probability distributions. For something to be a binomial probability distribution, there are 4 criteria that must be satisfied. The first is that there must be a fixed number of trials, and that means that a procedure will be performed a set number of times, a fixed number of times, and that fixed number of trials, we call that n. N is our fixed number of trials. The second criteria is that all of our trials are independent. In other words, the outcome of one trial will not affect the outcome of another trial. The third criteria is that only 2 possible outcomes are possible. Okay, so only 2 outcomes can occur. All right, and so we call those outcomes when we decide which one will be considered a success and the other is considered a failure. Now that doesn't mean that one is a failure and one is really a success. It just in statistics we typically call them the success and the failure. So 2 possibilities. And then the fourth criteria is the probability of each possible outcome is constant. In other words, the probability of a success, which we call P, is constant. And the probability of a failure, which we call Q, is also constant. Okay, so let's define these variables that are based on this criteria. So I'm going to go on to another page. And if we're working with a binomial probability distribution, we say that n is the number of trials. It's a fixed number. And x is going to represent the number of successes. So we try something n times, and we'll be looking for one of the 2 outcomes that we call the success. And x represents the number of successes. As a matter of fact, if you think about it, n minus x, that would give you the number of failures. Now P, let's put another variable over here, P represents the probability of a success. Let's move that over a little bit. And Q represents the probability of a failure. Now P, because this is a probability distribution, the sum, P plus Q, should equal 1, which means that Q is actually equal to 1 minus P. So if we know P, we can find Q, because P plus Q equals 1. Now, there is a formula for finding the probability of n successes in n trials in a probability distribution. So let's write this out. The probability of n, it's x, of n successes in n trials is equal to the following formula. It is equal to, remember factorial, n factorial divided by n minus x factorial times x factorial. We had factorial in a previous lesson, times p raised to the x times q raised to the n minus x. This formula gives us the probability of x successes in n trials. I'm going to grab this formula and we're going to use it in the next slide in an example. So let me copy this. If a couple decided to have 5 children, what is the probability that they will have exactly 3 girls? Okay, so 5 children, 3 of them are girls. So here's our probability of x successes in n trials. Okay, in this case, the n, which is the number of trials, is 5 because there are 5 children. A success in this particular case is considered a girl because they want to have exactly 3 girls. The probability of having a girl is 1/2. And the probability of not having a girl is also 1/2. That would be the probability of a boy. So this is all the information we need to find the probability of having 3 girls out of 5 children. So we're going to use the formula above. And we start with n factorial, so that's 5 factorial. We can use our calculator for this if we want. And then underneath we have n minus x, so 5 minus 3 factorial. And then times x factorial, x is 3 factorial. This is the first part of our formula. I'm going to sort of shorten this down a little bit here. Multiplied by p, which is 1/2, raised to the x, and x is 3, times q, which is also 1/2, raised to the 5 minus n minus x, 5 minus 3. All right, so let's simplify this. Let me move this over to the left just a little bit, and let's simplify this. Okay, again, we have our fraction. Let me draw my fraction bar. And on the top, I have 5 factorial. Well, 5 factorial is 5 times 4 times 3, and I can say 3 times 2 times 1, but I'm going to stop at 3 factorial. And then on the bottom, I have here 5 minus 3. Well, that's 2, so 2 factorial. 2 factorial is 2 times 1. And then I have 3 factorial here, so I'm going to write that 3 factorial. And let me move this over a little bit. And now I have 1/2 raised to the 3. And then I have 1/2 raised to the 5 minus 3, which is 2. Now, what I can do here is I can cancel out. This 3 factorial and this 3 factorial cancel out. This 2 cancels out with one of the 2's and the 4. So this fraction right here, all that's left on top is a 5 and times 2, which is 10, and on the bottom is a 1. So that highlighted piece, that's equal to 10. Put that back. Okay, so I end up with 10 times 1/2 to the 3rd is 1/8, and 1/2 squared is 1/4. And this reduces to 10. Divided by 8, and 8 is 1632. Right, 10 over 32. And that reduces to what? Cut it in half, 5/16. So the probability is 5/16. I'm going to put that into my calculator. And 5 divided by 16 is 0.312. 0.312. And we want to write that as percentage, 31.2%. So there's a 31.2% probability that a couple that decide to have 5 children will have exactly 3 girls. Okay, let's do one more problem here. What is the probability that 3 out of 5 people recognize the McDonald's brand name if 95% of the world's population recognize this brand name? Okay, so let's start again. I'll use blue. So we say we have 3 out of 5 people when 95% of the population recognize. Okay, so the total number of trials, or people, are 5. The number of successes, which is those that recognize the brand name, would be 3. The probability of a success, P, is 95%, 0.95. And Q, the probability of not having a success, that is 1 minus 0.95. So that's equal to 0.05. Okay, so I have all the bits that I need. I have N, X, P, and Q. So what is the probability that that 3 out of 5 people will recognize the McDonald's brand name? Remember, the formula is n factorial over n minus x factorial times x factorial times p raised to the x times q raised to the n minus x. Okay, n factorial is 5 factorial, and n minus x, that's 5 minus 3 factorial, and then x is 3, so 3 factorial, times p, which is 0.95, raised to the x, which is 3, times q, which is 0.05, raised to the n minus x, which is 5 minus 3, which is 2. Now, you may notice that this front piece here is identical to our previous problem. In fact, it's identical to this, which we already calculated. As a matter of fact, we calculated it to equal 10. So rather than go through all that process again, I'm going to put a 10 in there. Let me back out. So the green piece is actually equal to 10 times 0.95 cubed times 0.05 squared. I am going to use a calculator here. As a matter of fact, for much of this you can use a calculator. So let's go ahead and put this in. So I have 0.95 raised to the 3, and I multiply that by 0.05 raised to the 2, and if I multiply that by 10, I get 0.021. So I have that right. So I have, let's see, I have, just do this one more time, 10 times, it is 0.95 cubed, and I'm going to multiply that by 0.05 squared, and I get point 0.00214, and I'm going to move that decimal point over 1 to the right, so point 0.0214. And I'm going to double check this one because this one's actually going to book. Yes, this is And they actually, in the book, they round that up because they take it out of a table. So they end up with 0.02, and they call the next one 2. Okay, so this is the end of our second lesson in chapter 7.